Happy Friday! I thought I'd give you a little, you'll hear my kids in the background, they're still like, I thought I'd give you some Kofor family Christmas holiday ambiance in the background. You won't see my face very much longer, but just wanted to say hi. Hope you guys are being good for your substitute. And if you do not have paper and pen or pencil right now to take notes, you want to hit pause and make sure you grab that so that you are ready to take in all of the glory that is about to be the banquet table open response solution. Okay, so get that set up. You'll notice that I'm going to bounce back and forth between my desktop and some of the screens that you see every day, like your ConnectEd site, and also a bit of a Google. Here comes Bly. A Google Slides presentation. So, yeah, let's get started. So I'm going to go away, and you will just have your desktop view of what I see on my computer. Okay, I might have to hit pause because she's losing her mind, but I'll be back. So here you see the question that we worked on Tuesday. So I'm just going to read it to you so you have another idea as to what the question was asking. It says, Clarissa is helping her mom plan a surprise birthday party for Clarissa's Uncle Carlos. They are planning the party at Costanza's banquet hall. The drawings show how Costanza's hexagonal tables fit together to form long banquet tables. One guest sits on each side. In the drawing, each hexagonal table is a table and the dots are guests. So this is a configuration for one table. This is a configuration for two tables put together, and this is a configuration for three tables put together. So you should start to see a pattern between our number of guests and the tables that are lined up for those individuals to sit at. So 1A said the banquet hall has a total of 19 hexagonal tables to fit together in a line. What is the maximum number of guests that the banquet hall can seat with everyone at the same long table? So clearly it would be a waste of our time to draw 19 hexagons, put those dots around it, even to use those pattern blocks like we did for that 1, 2, and 3 configuration. And we definitely don't want to actually set up 19 tables in real life and put chairs around it. Again, waste of our time. So what we're looking for is a pattern for a relationship between the number of tables that we set up and the number of guests that can be placed around the outside of that table. You'll notice here when I put two tables together, I lose 2 seats on each table. Here, well, 1 seat on each table, 2 seats total. Here you actually lose 1, 2, 3, 4 individuals at that configuration. So it's really dependent on how many tables are put together. So what you want to pay attention to is zooming in on the picture and noticing how many people can sit at each table no matter how many I place together. So I'm going to jump over to a Google Slides presentation that I made for you. Ooh, sorry about that. Let me open it up. All right. So what you will notice, okay, some guiding questions that I asked of you. How many guests are at each table, not including the end seats? So if we look at this picture that I have drawn based on the 2 table configuration, and I drew these boxes to separate each table. And what you will notice is that each table I have 1, 2, 3, 4 guests. Again, at my second table, 1, 2, 3, 4 guests. And then I have the 2 people on the ends of the table. So how can I use this number to help me write my algebraic expression? So I notice that there's 4 people at each table, and then I'm adding a guest at each end. So I'm adding 2 seats to each configuration. So this is what remains constant. The 4 people at each table, and then the 2 guests at the end of the table. What is varying, what's going to be my variable in my expression, is going to be the number of tables. So for this situation you see in front of you, it's 2 tables. That's the number that's going to vary depending on how many tables I put together. Okay, so you'll notice here I said the end seats are also constant, blah, blah, blah. I already said that. Your value that varies is your variable. So let's take a look at that 3 people or that 3 table configuration. You'll notice I have 1, 2, 3 hexagonal tables. Again, each of those tables has 4 guests that are assigned to it. And then on the ends, I have those +2, those 2 guests, 1 person sitting at each end. So I should take this data and put it into a table. So not only do I see the visual or the picture relationship, but I can also start to put together some what's the word I'm looking for? Sorry, operations. I can use what I know about numbers being constant. I can use what I know about numbers varying. So this was the information that was given to me in those first pictures of my problem. With 1 table, I had 6 guests. So you want to start thinking about how can I get from 1 to 6. At 2 tables, I had 10 people. 3 tables, I had 14 people. So again, how do I get from this number, tables, to this number, guests? Knowing that 4 people can sit at each table, and I have those constant 2 people at each end. So the expression that I start to notice is 4 times the number of tables plus those 2 individuals at each end. So that's the expression that I put in my table up here at the top. Again, 1 table, 4 times 1 plus 2. So therefore I end up with 6 guests. 2 tables, 4 times 2 plus 2 gives me those 10 guests. 3 tables, 4 people at each table, each of those 3 tables, plus the 2 people at the end, I end up with 14 guests around 3 tables. So now I'm figuring out 19. That's the first question that they asked me. Again, in the real world, you don't want to actually set up 19 tables and put chairs around it. That's a waste of your time. So looking at that pattern or that algebraic expression that I've written, I can substitute the 19 in for the value that varies, that variable, 4 times 19 plus 2. Okay, and we notice that that comes out to be 78 guests around those 19 hexagonal tables. Okay, continuing my pattern, the next question asks me if I have 65 tables available, how many guests can sit there? All I need to do is substitute that 65 in for that value that varies. 4 times 65 plus the 2 guests at the end of my tables gives me 262 guests. So going back to the problem, oh, that's not it. All right, so going back to the problem, that answered A and B for number 1. Okay, we also answered number 2. Okay, number 3 says using your work for problems 1 to 2 to help you write an algebraic expression that represents the number of people that can fit at n tables, n being my value that varies. So going back to my table that I've established, my expression is up here. Let me see if I can bring your attention to it a little bit better. Let's turn it yellow. All right, so up here, you'll now see that your expression 4n plus 2, n being the number of tables, 4 being the constant of people at each of those tables, and 2 being the ends, okay, the people that sit at the ends of my table line. All right. Okay, so 4 asks, explain how the expression you wrote in problem 3 can help Clarissa plan a party at the banquet hall, no matter how many tables are available. Here you can talk about substituting those values. No matter how many tables I have, all I have to do is substitute that number in for n, multiply it by 4, and add the 2 end guests at my table. Easy peasy, lemon squeezy. 5A and 5B, you know try this, they're bonus, so we're not going to go over that. If you'd like to take your understanding from what we just did and extend it to those 2 problems, I wish you luck. I know you can do it. So let me go back to my recorder. Give me a minute. Oh, there I am. Again, I hope you guys are having a great day. Have a great weekend, getting ready for the holiday break. And remember, you cannot go back to this video after you turn on your iPad and get your paper back. So if you want to rewind this and take notes on something maybe that you didn't catch the first time, that's fine. Just after you turn your iPad back in, the substitute will give you your first attempt that you did on Tuesday, and then you'll have to go from your notes. So if I were you, I would go back and make sure you have all of the information that you need. Again, look for values that are constant. That's the 4 people at each table and the 2 guests at the end of the table. And the value that varies is our number of tables. Okay? Again, have a great weekend. I'll see you guys on Monday. And yeah, bye.